This is a demo video for Project 1 of Will's Plugins class. Here it is. As you can see, we have 4 different objects. We have a red object, which I'm also calling object A. We have green object B, blue object C, and then yellow for object D. Object A and D, or object A, let's start with object A. Object A is our harmonic exciter. So this is basically taking a sidechained path, saturating it, filtering it, and our harmonic blend knob here, we can blend it back into our original signal like so. So if I press sidechain listen, you can hear that the saturation is changing when I change this knob harmonic saturation, and when it's off and I change harmonic blend, it's going to blend that signal in. We can give it harmonic drive for the purposes of the high pass doing some gain reduction, so we have the harmonic drive to make up for that. Also, you might ask, why do we have attack release threshold sensitivity for the harmonic exciter? And you can see that we actually have this for each object. The way I coded this is for each object I have a function called doFCmod, except for object D, which is doGainMod. And this reads in all the parameters for a detector object and a filter object that I use. Like, I have separate filter objects and detectors for each set of knobs here. So in fact, if we listen to the sidechain path, you can actually hear the filter FC of the high pass being modulated. As well as over here on all of my meters, I have meters for each separate detection circuit. So we have for A, for B. You can see the A is moving. Yeah, and you can hear it working. Also, we have a knob that sets our saturation type. This is sort of a reduced version of my WaveShaper plugin where I had the different WaveShaper algorithms. We have the A tangent algorithm. I'm going to turn off this modulation for now. So here's A tangent, and Araya, which is a much gentler saturation. Also, in this case, the changing the saturation really doesn't do much, but that's okay. We have the other 2 modes for that. Moving on to object B, if we go down here to our switch object knob, this is a temporary knob right here because the idea is I wanted to implement this joystick blender. I managed to do it in my WaveShaper, but when trying to do it in here, I got some weird, for some reason I got dropouts when I just called a function that blends them together. I still don't fully understand how the joystick works and how I get the variable names for that and setting them. So I've just for the purpose of time and getting it working, I've implemented this switch object. So if we go down here and we switch it to object B, this is object B and C are 2 envelope followers, and the difference here between your envelope follower and my envelope follower is we have the filter select, and we also have a dry wet because we're using the same doFC function. Yeah, doShaper actually. doShaper is the function. As you can see, it's getting called for each of the objects, and in doShaper I have this line right here which does my blending. So I call doShaper for all of my objects, but I have a parameter in there. As you can see, true is the only time this is true is on object A, because true means we're doing shaping, and then everywhere else is false. We're just using the blending of the doShaper function. So let's go ahead and listen to object B. And you can watch BL and BR right now. Those are the detector for object B. Kind of hard to hear with a first order low pass, so let's switch it to second order. Erase our cue. And there you go, it's working. I've also implemented that MMA low pass filter, and that also works. And down here, you'll notice a button next to Sidechain Listen called Reverse. And this is like my fun sort of A feature. I wanted this to be it, but I couldn't figure this one out in time. So I implemented this reverse. And if you press this, it's basically going to take the direction. So normally it's modulating up from your filter frequency. Now it's going to modulate down from your filter frequency. So to hear this, we're going to need to adjust our filter FC a little bit higher, and we'll have to play with our detection settings to get something noticeable. So yeah, you can hear it there. If we change it back, since it's already such a high filter cutoff, we'll have to pull this down. And yeah, as you can see, it's doing the direction again. Object C is basically the same thing. Also, let me do the dry wet real quick. So you can only have, you can blend that with the dry signal as you please for each of these different objects. And, you know, in the future, this will be also blendable. So we have dry wet blends for each object, and then you can further blend it here. In the future, object C is the same thing. We don't have to go through that. And object D is the high frequency exciter. So basically the same logic as the object B and C, but in this case, we're using, instead of FC mod, we're doing gain mod. Go ahead and go to that function. So where do FC mod is setting your filter FC and doing your modulation from filter frequency to max filter frequency, and as you can see, here's the logic for reverse. Pretty simple, but effective. Doing the same thing here, but set filter gain instead, and it's doing boost cut mod. So another implementation, or another thing I had to implement for this filter, is I had to make a different filter object for my sidechain listen. So let's listen to that. Let's get it to a point where it's actually doing some modulation. And we also have a filter select over here. So right now it's the high pass. The high shelf. Let's give it some boost. And actually, I'm going to go ahead and go into my graphs just to show that it is indeed a high shelf. Yep. And tune this up. Let's tune it down and give it some extra boost. Get extra noticeable. There we go. Go ahead and give it a listen. So, as you see, it's working because it's making it sound distorted and clipped. Let's go to peak 2. So I've got, you can select between high shelf, peak 2 non-constant Q, and peak 2 constant Q. So let's go ahead and test our constant Q and non-constant Q. As you can see, there they are. and you can't really see it moving because that's work with this thing. So let's move constant Q. Here we are. There's constant Q, and if we move our boost up, well, you can't really see it because of the resolution of the graph, but yeah, that's the constant Q, and it is working. So if we listen to it, and then sidechain listen, it's going to allow us to tune that filter without the modulation moving it. So that is my demo for this plugin. And if you have any questions, then email me. And this is nowhere near finished. I'm going to come back to this later, even though this is like something I'm turning in now. I'm going to come back to this later and implement this joystick control. And other blend modes, I want to have perhaps a crossfader knob or some sort of sequencer element that will let me sequence between these 4 objects on some MIDI, some beat that's received by MIDI, but obviously I don't know how to do that yet. So this is how it is right now. Okay, there it is.